Hi, welcome to our channel of IGNOU Audiobooks, Indira Gandhi National Open University, School of Computer and Information Sciences, SOCIS, Postgraduate Diploma in Computer Applications, PGDCA, new. Semester I. MCS 201 Programming in C and Python. Block 1 An Introduction to C. Unit-4 Arrays and Strings. 4.0 Introduction. C language provides 4 basic data types, int, char, float and double. We have learnt about them in Unit 2. These basic data types are very useful, but they can handle only a limited amount of data. As programs become larger and more complicated, it becomes increasingly difficult to manage the data. Variable names typically become longer to ensure their uniqueness. And the number of variable names makes it difficult for the programmer to concentrate on the more important task of correct coding. Arrays provide a mechanism for declaring and accessing several data items with only one identifier, thereby simplifying the task of data management. Many programs require the processing of multiple, related data items that have common characteristics like list of numbers, marks in a course, or enrollment numbers. This could be done by creating several individual variables. But this is a hard and tedious process. For example, suppose you want to read in 5 numbers and print them out in reverse order. You could do it the hard way as main intl 2 3 a 4 a 5 scanf %d 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 andal under 2 under 3 under 5 printf %d 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 5 4 3 2 1. Does it look good if the problem is to read in 100 or more related data items and print them in reverse order? Of course, the solution is the use of the regular variable names al, a 2 and so on. But to remember each and every variable and perform the operations on the variables is not only tedious a job and disadvantageous too. One common organizing technique is to use arrays in such situations. An array is a collection of similar kind of data elements stored in adjacent memory locations and are referred to by a single array name. In the case of C, you have to declare and define array before it can be used. Declaration and definition tell the compiler the name of the array, the type of each element, and the size or number of elements. To explain it, let us consider to store marks of 5 students. They can be stored using 5 variables as follows: int rrl, ar2, ar3, ar4, ar5. Now, if we want to do the same thing for 100 students in a class, then one will find it difficult to handle 100 variables. This can be obtained by using an array. An array declaration uses its size in brackets. For above example, we can define an array as int ar 100, where ar is defined as an array of size 100 to store marks of integer data type. Each element of this collection is called an array element, and an integer value called the subscript is used to denote individual elements of the array. An AR array is the collection of 200 consecutive memory locations referred as below. Look at the screen. Figure 4.1, representation of an array. In the above figure, as each integer value occupies 2 bytes, 200 bytes were allocated in the memory. This unit explains the use of arrays, types of arrays, declaration and initialization with the help of examples in the first few sections, and later on focuses on string handling in C programming language. 4.1 Objectives. After going through this unit, you will be able to declare and use arrays of one dimension, initialize arrays, use subscripts to access individual array elements, write programs involving arrays, do searching and sorting, handle multidimensional arrays, define, declare and initialize a string, discuss various formatting techniques to display the strings, and discuss various built-in string functions and their use in manipulation of strings. 4.2 Array declaration. Before discussing how to declare an array, first of all let us look at the characteristic features of an array. Array is a data structure storing a group of elements, all of which are of the same data type. All the elements of an array share the same name, and they are distinguished from one another with the help of an index. Random access to every element using a numeric index, subscript. A simple data structure, used for decades, which is extremely useful. Abstract data type, ADT, list is frequently associated with the array data. Structure. The declaration of an array is just like any variable declaration with additional size part, indicating the number of elements of the array. Like other variables, arrays must be declared at the beginning of a function. The declaration specifies the base type of the array, its name, and its size or dimension. In the following section we will see how an array is declared. 4.2.1 Syntax of array declaration. Syntax of array declaration is as follows. Data type array underscore name, constant size. Data type refers to the type of elements you want to store. Constant size is the number of elements. The following are some of declarations for arrays. int char, 80. Float fir, 500. Static int year, 80. Char char, 40. There are two restrictions for using arrays in C. The amount of storage for a declared array has to be specified at compile time before execution. This means that an array has a fixed size. The data type of an array applies uniformly to all the elements. For this reason, an array is called a homogeneous data structure. 4.2. To size specification. The size of an array should be declared using symbolic constant rather a fixed integer quantity. The subscript used for the individual element is of a integer quantity. The use of a symbolic constant makes it easier to modify a program that uses an array. All reference to maximize the array size can be altered simply by changing the value of the symbolic constant. Please refer to Unit 2 for details regarding symbolic constants. To declare size as 50, use the following symbolic constant, size, defined. Hash define size 50. The following example shows how to declare and read values in an array to store marks of the students of a class. 4.3 Array initialization. Arrays can be initialized at the time of declaration. The initial values must appear in the order in which they will be assigned to the individual array. Elements, enclosed within the braces and separated by commas. In the following section, we see how this can be done. 4.3.1 Initialization of array elements in the declaration. The values are assigned to individual array elements enclosed within the braces and separated by comma. Syntax of array initialization is as follows. Data type array name, size, is equal to val1 val2 val_n. Val1 is the value for the first array element, val2 is the value for the second element, and val_n is the value for the n array element. Note that when you are initializing the values at the time of declaration, then there is no need to specify the size. Let us see some of the examples given below. Int digits, 10, is equal to 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Int digits is equal to 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Int vector, 5, is equal to 12, 2, 33, 21, 13. Float temperature, 10, is equal to 31.2, 22.3, 41.4, 33.2, 23.3, 32.3, 41.1, 10.8, 11.3, 42.3. Double width is equal to 17.333334561.2 1.21212113, to 22.191345. Int height, 10, is equal to 60, 70, 68, 72, 68. 4.3.2 Character array initialization. The array of characters is implemented as strings in C. Strings are handled differently as far as initialization is concerned. A special character called null character \0 implicitly suffixes every string. When the external or static string character array is assigned a string constant, the size specification is usually omitted and is automatically assigned. It will include the \0 character added at end. For example, consider the following two assignment statements. Char thing 3 is equal to 10. Char thing is equal to 10. In the above two statements, the assignments are done differently. The first statement is not a string but simply an array storing three characters t, I, and n and is same as writing char thing 3 is equal to t, I, n, whereas the second one is a 4-character string tin \0. The change in the first assignment, as given below, can make it a string. Char thing 4 is equal to 10. 4.4 subscript. To refer to the individual element in an array, a subscript is used. Refer to the statement we used in the example 4.1. Scanf %d and stud_marks I. Subscript is an integer type constant or variable name whose value ranges from 0 to size 1, where size is the total number of elements in the array. Let us now see how we can refer to individual elements of an array of size 5. Consider the following declarations. Char country is equal to India. Int stud is equal to 1, 2, 3, 4, 5. Here both arrays are of size 5. This is because the country is a char array and initialized by a string constant India, and every string constant is terminated by a null character \0. And stud is an integer array. Country array occupies 5 bytes of memory space, whereas stud occupies size of 10 bytes of memory space. The following table 4.1 shows how individual array elements of country and stud arrays can be referred. Table 4.1 Reference of individual elements. Look at the screen. 4.5 Processing the arrays. For certain applications, the assignment of initial values to elements of an array is required. This means that the array be defined globally, extern, or locally as a static array. Let us now see in the following example how the marks into subjects, stored into different arrays, can be added to give another array and display the average marks in the below example. Example 4.3. Write a program to display the average marks of each student, given the marks in 2 subjects for 3 students. Asterisk program to display the average marks of 3 students asterisk. Hash include stdio. H. Hash define size 3. Main. Int I is equal to 0. Float stud underscore marks 1, size, asterisk subject 1 array declaration asterisk. Float stud underscore marks 2, size, asterisk subject to array declaration asterisk. Float total underscore marks, size. Float average, size. Print, \n enter the marks in subject 1 out of 50 marks, \n. For I is equal to 0, I size, I++. Print, student no is equal to %d, I plus 1. Print, enter the marks is equal to scanf, %f, and stud underscore marks 1, I. Print, \n enter the marks in subject to out of 50 marks \n. For I is equal to 0, I size, I++. Print, student no is equal to %d, I plus 1. Print, please enter the marks is equal to scanf, %f, and stud underscore marks 2, I. For I is equal to 0, I size, I++. Total underscore marks, I, is equal to stud underscore marks 1, I, plus stud underscore marks 2, I. Average, I, is equal to total underscore marks, I, 2. Printf, student no. Is equal to %d, average is equal to %f backslash n, I plus 1, average, I. Output. Enter the marks in subject 1 out of 50 marks. Student no. Is equal to 1, enter the marks is equal to 23. Student no. Is equal to enter the marks is equal to 35. Student no. Is equal to 3, enter the marks is equal to 42. Enter the marks in subject 2 out of 50 marks. Student no. Is equal to 1, enter the marks is equal to 31. Student no. Is equal to enter the marks is equal to 35. Student no. Is equal to 3, enter the marks is equal to 40. Student no. Is equal to 1, average is equal to 27.000000. Student no. Is equal to 2, average is equal to 35.000000. Student no. Is equal to 3, average is equal to 41.000000. 4.6 multidimensional arrays. Suppose that you are writing a chess-playing program. A chessboard is an 8 by 8 grid. What data structure would you use to represent it? You could use an array that has a chessboard-like structure, i.e., a two-dimensional array, to store the positions of the chess pieces. Two-dimensional arrays use two indices to pinpoint an individual element of the array. This is very similar to what is called algebraic notation, commonly used in chess circles to record games and chess problems. In principle, there is no limit to the number of subscripts or dimensions an array can have. Arrays with more than one dimension are called multidimensional arrays. While humans cannot easily visualize objects with more than 3 dimensions, representing multidimensional arrays presents no problem to computers. In practice, however, the amount of memory in a computer tends to place limits on the size of an array. A simple 4-dimensional array of double precision numbers, merely 20 elements wide in each dimension, takes up 24*8 or 1,280,000 bytes of memory, about a megabyte. For example, you have 10 rows and 10 columns, for a total of 100 elements. It's really no big deal. The first number in brackets is the number of rows, the second number in brackets is the number of columns. So, the upper left corner of any grid would be element 0, 0. The element to its right would be 0, 1, and so on. Here is a little illustration to help. 3-dimensional arrays, and higher, are stored in the same way as the 2-dimensional ones. They are kept in computer memory as a linear sequence of variables, and the last index is always the one that varies fastest, then the next to last, and so on. 4.6.1 Multidimensional Array Declaration. You can declare an array of 2 dimensions as follows. Data type array underscore name, size, size. In the above example, variable underscore type is the name of some type of variable, such as int. Also, sizzle and size2 are the sizes of the array's first and second dimensions, respectively. Here is an example of defining an 8 by 8 array of integers, similar to a chessboard. Remember, because carries are 0-based, the indices on each side of the chessboard array run 0 through 7, rather than 1 through 8. The effect is the same, a two-dimensional array of 64 elements. int chessboard, 8, 8. To pinpoint an element in this grid, simply supply the indices in both dimensions. 4.6 Point to initialization of two-dimensional arrays. If you have an mxn array, it will have m*n elements and will require m*n element size bytes of storage. To allocate storage for an array, you must reserve this amount of memory. The elements of a two-dimensional array are stored row-wise. If table is declared as int table 2, 3 is equal to 1, 2, 3, 4, 5, 6, it means that element table 0, 0 is equal to 1. Table 0, 1 is equal to 2. Table 0, 2 is equal to 3. Table 1, 0 is equal to 4. Table 1, 1 is equal to 5. Table 1, 2 is equal to 6. The neutral order in which the initial values are assigned can be altered by including the groups inside main enclosing brackets, like the following. Initialization as above. int table 2, 3 is equal to 1, 2, 3, 4, 5, 6. The value within innermost braces will be assigned to those array elements whose last subscript changes most rapidly. If there are few remaining values in the row, they will be assigned zeros. The number of values cannot exceed the defined row size. int table 2, 3 is equal to 1, 2, 3, 4. It assigns values as table 0, 0 is equal to 1. Table 0, 1 is equal to 2. Table 0, 2 is equal to 3. Table 1, 0 is equal to 4. Table 1, 1 is equal to 0. Table 1, 2 is equal to 0. Remember that C language performs no error checking on array bounds. If you define an array with 50 elements and you attempt to access element 50, the 51st element, or any out-of-bounds index, the compiler issues no warnings. It is the programmer's task to check that all attempts to access or write to arrays are done only at valid array indexes. Writing or reading past the end of arrays is a common programming bug and is hard to isolate. 4.7 Introduction to Strings. In the previous unit, we have discussed numeric arrays, a powerful data storage method that lets you group a number of same-type data items under the same group name. Individual items, or elements, in an array are identified using a subscript after the array name. Computer programming tasks that involve repetitive data processing lend themselves to array storage. Like non-array variables, arrays must be declared before they can be used. Optionally, array elements can be initialized when the array is declared. In the earlier unit, we had just known the concept of character arrays, which are also called strings. String can be represented as a single-dimensional character type array. C language does not provide the intrinsic string types. Some problems require that the characters within a string be processed individually. However, there are many problems which require that strings be processed as complete entities. Such problems can be manipulated considerably through the use of special string-oriented library functions. Most of the C compilers include string library functions that allow string comparison, string copy, concatenation of strings, etc. The string functions operate on null-terminated arrays of characters and require the header string h. The use of the sum of the string library functions are given as examples in this unit. 4.8 Declaration and initialization of strings. Strings in C are group of characters, digits, and symbols enclosed in quotation marks, or simply we can say the string is declared as a character array. The end of the string is marked with a special character, the \0, null character, which has the decimal value 0. There is a difference between a character stored in memory and a single character string stored in a memory. The character requires only 1 byte, whereas the single character string requires 2 bytes, 1 byte for the character and other byte for the delimiter. Declaration of strings. A string in C is simply a sequence of characters. To declare a string, specify the data type as char and place the number of characters in the array in square brackets after the string name. The syntax is shown as below. Char string name, size. For example, char name, 20. Char address, 25. Char city, 15. Initialization of strings. The string can be initialized as follows. char name 8 is equal to PROGRAM \0. Each character of string occupies 1 byte of memory on 16-bit computing. The size of character is machine-dependent and varies from 16-bit computers to 64-bit computers. The characters of strings are stored in the contiguous, adjacent memory locations. The C compiler inserts the null \0 character automatically at the end of the string. So initialization of the null character is not essential. You can set the initial value of a character array when you declare it by specifying a string literal. If the array is too small for the literal will be truncated. If the literal, including its null terminator, is smaller than the array, then the final characters in the array will be undefined. If you don't specify the size of the array, but do specify a literal, then C will set the array to the size of the literal, including the null terminator. Char str4 is equal to UNIX. Char str5 is equal to UNIX \0. Char str3. Char str is equal to Unix. Char str4 is equal to Unix. Char str9 is equal to Unix. All of the above declarations are legal. But which ones don't work? The first one is a valid declaration, but will cause major problems because it is not null terminated. The second example shows a correct null terminated string. The special escape character \0 denotes string termination. The fifth example suffers the size problem. The character array str is of size 4 bytes, but it requires an additional space to store \0. The fourth example, however, does not. This is because the compiler will determine the length of the string and automatically initialize the last character to a null terminator. The strings not terminated by a \0 are merely a collection of characters and are called as character arrays. String constants. String constants have double quote marks around them and can be assigned to char pointers. Alternatively, you can assign a string constant to a char array, either with no size specified, or you can specify a size, but don't forget to leave a space for the null character. Suppose you create the following two code fragments and run them. *fragment1*. Char *s. S is equal to hello. Print %s\n s. *fragment2*. Char s 100. strcpy s hello. Print %s\n s.
These two fragments produce the same output, but their internal behavior is quite different. In fragment 2, you cannot say s is equal to hello. To understand the differences, you have to understand how the string constant table works in C. When your program is compiled, the compiler forms the object code file, which contains your machine code and a table of all the string constants declared in the program. In fragment 1, the statement s is equal to hello causes s to point to the address of the string hello in the string constant table. Since this string is in the string constant table, and therefore technically a part of the executable code, you cannot modify it. You can only point to it and use it in a read-only manner. In fragment 2, the string hello also exists in the constant table, so you can copy it into the array of characters named s. Since s is not an address, the statement s is equal to hello will not work in fragment 2. It will not even compile. Example 4.6. Write a program to read a name from the keyboard and display message hello onto the monitor. Asterisk program that reads the name and display the hello along with your name asterisk. Hush include stdio. H. Main. Char name, 10. Print, \n enter your name happy smiley. Scanf, %s, name. Print, hello %s\n, name. Output. Enter your name, Alex. Hello Alex. In the above example declaration char name, 10, allocates 10 bytes of memory space on 16-bit computing to array name. We are passing the base address to scanf function, and scanf function fills the characters typed at the keyboard into array until enter is pressed. The scanf places \0 into array at the end of the input. The print function prints the characters from the array onto monitor, leaving the end of the string \0. The %s used in the scanf and print functions is a format specification for strings. 4.9 Display of strings using different formatting techniques. The print function with %s format is used to display the strings on the screen. For example, the below statement displays entire string. Print %s name. We can also specify the accuracy with which character array string is displayed. For example, if you want to display first 5 characters from a field width of 15 characters, you have to write as print %15.5s name. If you include minus sign in the format, e.g. %10.5s, the string will be printed left justified. Print %10.5s name. Example 4.7. Write a program to display the string uniques in the following format: U, UN, uni, uniques, uniques, uni, U. Asterisk program to display the string in the above shown format asterisk. Hush include stdio. H. Main. INTX, Y. Static char string is equal to uniques. Print \n. For x is equal to 0, x for x plus plus. Y is equal to x plus 1. Asterisk reserves 4 character of space onto the monitor and minus sign is for left justified asterisk. Print %4. Asterisk s \n, y, string. Asterisk, and for every loop the asterisk is replaced by value of y asterisk. Asterisk y value starts with 1 and for every time it is incremented by 1 until it reaches to 4 asterisk. For x is equal to 3, x is equal to 0, x. Y is equal to x plus 1. Print %4 asterisk s \n, y, string. Asterisk y value starts with 4 and for every time it is decrements by 1 until it reaches to 1 asterisk. Output. U. UN. Uni. Uniques. Uniques. Uni. UN. U. 4.10 Array of strings. Array of strings are multiple strings, stored in the form of table. Declaring. Array of strings is same as strings, except it will have additional dimension too. Store the number of strings. Syntax is as follows. Char array name, size, size. For example, char names, 5, 10. Where names is the name of the character array and the constant in first square. Brackets will gives number of string we are going to store, and the value in second square bracket will gives the maximum length of the string. 4.11 Built-in string functions and applications. The header file string H contains some string manipulation functions. The following is a list of the common string managing functions in C. 4.11.1 String function. The string function returns the length of a string. It takes the string name as argument. The syntax is as follows. N is equal to string str, where str is name of the string and n is the length of the string returned by string function. Example 4.10. Write a program to read a string from the keyboard and to display the length of the string onto the monitor by using string function. Asterisk program to illustrate the string function to determine the length of a string asterisk. Hash include stdio. H. Hash include string. H. Main. Char name 80. Int length. Print, enter your name. Gets name. Length is equal to string name. Print, your name has %d characters \n length. Output. Enter your name, Tyron. Your name has 5 characters. 4.11.2 strcpy function. In C, you cannot simply assign one character array to another. You have to copy element by element. The string library, string H, contains a function called strcpy for this purpose. The strcpy function is used to copy one string to another. The syntax is as follows. strcpy, str1, str2. Where str1, str2 are two strings. The content of string str2 is copied onto string str1. Example 4.11. Write a program to read a string from the keyboard and copy the string onto the second string and display the strings onto the monitor by using strcpy function. Asterisk program to illustrate strcpy function asterisk. Hash include stdio. H. Hash include string. H. Main. Char first 80, second 80. Print, enter a string. Gets first. strcpy, second, first. Print, \n first string is %s and second string is %s\n, first, second. Output. Enter a string, Adams. First string is Adams and second string is Adams. 4.11. 3 strcmp function. The strcmp function in the string library function which compares two strings character by character and stops comparison when there is a difference in the ASCII value or the end of any one string and returns ASCII difference of the characters, that is integer. If the return value 0 means the two strings are equal, a negative value means that first is less than second, and a positive value means first is greater than second. The syntax is as follows. N is equal to strcmp, str1, str2. Where str1 and str2 are two strings to be compared and n is returned value of deferred characters. Example 4.12. Write a program to compare two strings using string compare function. Asterisk, the following program uses the strcmp function to compare two strings. Asterisk. Hash include stdio. H. Hash include string. H. Main. Char first 80, second 80. Int value. Print, enter a string. Gets first. Print, enter another string. Gets second. Value is equal to strcmp, first, second. If value is equal to 0, puts the two strings are equal. Else if value 2000, puts the first string is smaller. Else if value 2000, puts the first string is bigger. Output. Enter a string, Mohand. Enter another string, Mohant. The first string is smaller. 4.11.4 stcat function. The stcat function is used to join one string to another. It takes two strings as arguments. The characters of the second string will be appended to the first string. The syntax is as follows. stcat, str1, str2. Where str1 and str2 are two string arguments, string str2 is appended to string str1. Example 14.13. Write a program to read two strings and append the second string to the first string. Asterisk program for string concatenation asterisk. Hash include stdio. H. Hash include string. H. Main. Char first, 80, second, 80. Print, enter a string. Gets, first. Print, enter another string. Gets, second. stcat, first, second. Print, backslash n the two strings joined together, %s\n, first. Output. Enter a string, borex. Enter another string, banks. The two strings joined together, borex banks. 4.11.5 strlwr function. The strlwr function converts uppercase characters of string to lowercase characters. The syntax is as follows. strlwr, str1. Where str1 is string to be converted into lowercase characters. Example 4.14. Write a program to convert the string into lowercase characters using inbuilt function. Asterisk program that converts input string to lowercase characters asterisk. Hash include stdio. H. Hash include string. H. Main. Char first, 80. Print, enter a string. Gets, first. Print, lowercase of the string is %s, strlwr, first. Output. Enter a string, brooks. Lowercase of the string is brooks. 4.11.6 stref function. The stref function reverses the given string. The syntax is as follows. Stref, str. Where string str will be reversed. Example 4. 15. Write a program to reverse a given string. Asterisk program to reverse a given string asterisk. Hash include stdio. H. Hash include string. H. Main. Char first, 80. Print, enter a string. Gets, first. Print, backslash in reverse of the given string is %s, strev, first. Output. Enter a string, Adania. Reverse of the given string is inada. 4.11.7 strspn function. The strspn function returns the position of the string, where first string mismatches with second string. The syntax is as follows. N is equal to strspn, first, second. Where first and second are two strings to be compared, n is the number of character from which first string does not match with second string. Example 4.16. Write a program which returns the position of the string from where first string does not match with second string. Asterisk program which returns the position of the string from where first string does not match with second string asterisk. Hash include stdio. H. Hash include string. H. Main. Char first, 80, second, 80. Print, enter first string. Gets, first. Print, backslash and enter second string. Gets, second. Print, backslash and after %t characters there is no match, strspn, first, second. Output. Enter first string, Alexander. Enter second string, Alex Smith. After 4 characters there is no match. 4.11.8 Other string functions. strncpy function. The strncpy function same as strcpy. It copies characters of one string to another string up to the specified length. The syntax is as follows: strncpy, str1, str2, 10. Where str1 and str2 are two strings. The 10 characters of string str2 are copied onto string str1. Strict function. The strict function is same as strcmp, except it compares two strings, ignoring the case, lower and upper case. The syntax is as follows: n is equal to strict str1, str2. strncmp function. The strncmp function is same as strcmp, except it compares two strings up to a specified length. The syntax is as follows: n is equal to strncmp, str1, str2, 10. Where 10 characters of str1 and str2 are compared and n is returned value of deferred characters. strchr function. The strchr function takes two arguments, the string and the character whose address is to be specified, and returns the address of first occurrence of the character in the given string. The syntax is as follows: cp is equal to strchr, str, c. Where str is string and c is character and cp is character pointer. Stset function. The stset function replaces the string with the given character. It takes two arguments, the string and the character. The syntax is as follows: stset, first, ch. Where string first will be replaced by character ch. strchr function. The strchr function takes two arguments, the string and the character whose address is to be specified, and returns the address of first occurrence of the character in the given string. The syntax is as follows: cp is equal to strchr, str, c. Where str is string and c is character and cp is character pointer. Start function. The start function is the same as stcat, except that it appends up to specified length. The syntax is as follows: start str1, str2, 10. Where 10 character of the str2 string is added into str1 string. Struper function. The struper function converts lower case characters of the string to upper case characters. The syntax is as follows: struper, str1. Where str1 is string to be converted into upper case characters. str function. The str function takes two arguments, address of the string and second string as inputs, and returns the address from where the second string starts in the first string. The syntax is as follows: cp is equal to str, first, second. Where first and second are two strings, cp is character pointer. 4.12 Summary. Like other languages, C uses arrays as a way of describing a collection of variables with identical properties. The group has a single name for all its members, with the individual member being selected by an index. We have learnt in this unit the basic purpose of using an array in the program, declaration of array and assigning values to the arrays and also the string handling functions. All elements of the arrays are stored in the consecutive memory locations. Without exception, all arrays in C are indexed from 0 up to 1 less than the bound given in the declaration. This is very puzzling for a beginner. Watch out for it in the examples provided in this unit. One important point about array declarations is that they don't permit the use of varying subscripts. The numbers given must be constant expressions which can be evaluated at compile time, not run time. As with other variables, global and static array elements are initialized to 0 by default, and automatic array elements are filled with garbage values. In C, an array of type char is used to represent a character string, the end of which is marked by a byte set to 0, also known as a null character. Whenever the arrays are passed to function, their starting address is used to access rest of the elements. This is called call by reference. Whatever changes are made to the elements of an array in the function, they are also made available in the calling part. The formal argument contains no size specification except for the rightmost dimension. Arrays and pointers are closely linked in C. Multidimensional arrays are simply arrays of arrays. To use arrays effectively, it is a good idea to know how to use pointers with them. More about the pointers can be learned from Unit-7, Block -2. Strings are sequence of characters. Strings are to be null terminated if you want to use them properly. Remember to take into account null terminators when using dynamic memory allocation. The string H library has many useful functions. Losing the \0 character can lead to some very considerable bugs. Make sure you copy \0 when you copy strings. If you create a new string, make sure you put \0 in it. And if you copy one string to another, make sure the receiving string is big enough to hold the source string, including \0. Finally, if you point a character pointer to some characters, make sure they end with \0. Thank you.